We'll just figure out largely how to use SimXpress, what it does, and the differences between it and a regular simulation license. And on that SolidWorks screen is a smoker. Now, I did not model this. I am not that good. I'm the analyst, right? But a good friend of mine, a good coworker of mine, modeled this up. It is a smoker. It's built up in an assembly, so it's got wheels, moving parts, grills, a lot of detailed parts that I don't necessarily need for an analysis, an FEA analysis. Okay, so this is the part file, and I've simplified it just slightly from what you saw in the assembly. I took out a lot of the extra components like the handles and the temperature gauges and the damper that was on this chimney stack. Things like that that weren't really going to affect the overall stress. Okay, now let's get started with what SimXpress can do. So if I'm here inside of my SolidWorks install, and again, this could be any level of SolidWorks, SolidWorks Standard, SolidWorks Professional, or SolidWorks Premium, you have access to SimXpress. It's here in the Evaluate tab, where on the right-hand side, you're going to see Simulation Express Analysis Wizard. The first time that you launch it, you're going to see a pop-up like this. It says Enable SimXpress. It's asking for a code, and you might think, oh, that means I got to pay for something. Absolutely not. This is just asking you to log in to your SolidWorks login. All it takes is an email and a password. It's not paid either. So you log into your SolidWorks login, and you'll get the SimXpress code, okay? You just click that link. I've already done that, so when I click SimXpress, it launches the product. And it's a wizard set up on the right-hand side of my screen, and it's about 4 or 5 steps. We'll go through those together. Let me start with options. Options is where I would set my unit system, that all my results are going to be in, and where my results are going to be saved. Okay, now as I hit next, I get my first issue, my first warning. Let's check this out in the top left-hand corner. SolidWorks SimXpress has detected multi-bodies. Currently, we only support one body. So that's a limitation of SimXpress, our first one. It can only do a single body. So you might have heard some verbiage online that says things like only one part. It's truly only one body. So can't even do multi-body parts, okay? But that doesn't stop us. We can still do something here. So let's take out a piece of this multi-body and analyze it separately. If you have a multi-body part file like this, generally modeled with something like weldments or sheet metal, you're going to have a cut list folder. In that cut list folder, you can right click on any of your solid bodies and say insert into new part. With this, you can then left click on various bodies and that'll set them out into a separate part file, okay? I've already done that, so to save us 30 seconds, I'll just jump over to this model. So I exported about 4 pieces of the firebox. So kind of the outside piece, part of the door, another part of the door, and then part of the back panel here where it connects to the larger piece of the smoker. So this is already 4 bodies. We know that's not going to work for SimXpress. So step 1 is to use some SolidWorks features. We're going to use the SolidWorks feature of combine. Combine merges bodies together. See how this is now one piece? There's no extra line between those. So combine is combining the bodies together. Now, as I did that, I see still a black line around this piece of the door. Let me zoom in. I see there was a gap here, right? There was some clearance set in for that door, but that's going to cause a problem with my SimXpress study. So we do some hack and slash modeling. That's what I like to call it. I'm going to throw in a little boss extrude to close that off. With that, I have a single part file that I can run a SimXpress study on. Let's go ahead and launch that again. So I already started one. Let's start over from the beginning though. Let's hit start over. I'll permanently delete my results. This is kind of important to know. You can only have one SimXpress study associated with the part file or saved into the part file. You can't have more than one. Let's start from the beginning. Okay, so here we are at the very first step of our wizard, and it's asking for me to put in some fixtures. Well, what are fixtures? The wizard gives us a couple animations explaining this. So if we check out what's going on here, those green arrows in that little animation, that is a fixture. It's rigidly holding the face in place. It cannot move at all. Let's look at some other examples. So this is kind of like a bending beam. See how it's held there at the bottom and not moving at the first one? So that fixture is holding in place, keeps that face totally rigid. And that is the only thing we can do here. I've got a totally rigid fixture type. Any face that I click cannot move at all. Another good example here on the left-hand side with this little beam. So this firebox, it butts up against the smoker. So I'm going to make a pretty intense assumption that this face pretty much doesn't move because it's butting up against the larger smoker. Now we also know that this component is sitting on some weldment legs, right? They've kind of attached right here and gone down to the wheels. So those could also be acting as a restraint, but how am I going to click them? I don't have them here. Let's skip right out of SimXpress for a second and go back to SolidWorks modeling. Inside of General SolidWorks, there's a tool called Split Line. Split Line lets you take a sketch and project it onto a face. And it cuts out that face just slightly. It's not actually changing the geometry at all. It's not changing the mass or anything like that. It's just splitting the face up into two separate faces. That way you can select one for something like a SimXpress study. So now that I've got those extra cutouts for the legs, I'll come back to my SimXpress study, edit my fixture, and include those legs as well. All right, that's our fixture. So what did we just learn? Besides a single body, we can only do a totally fixed face. But the tip there is for split lines. All right, let's get into the next step of the wizard. I'm going to hit next. Okay, I've got two types of loads that I can apply. I can do a force or I can do a pressure. Let's kind of fake a pressure vessel study here. Let's add a pressure to the inside faces of this firebox. I'm going to add pressure. Now when I click on the inside faces, a nice trick, and I'll show you guys how I did this, is to take advantage of these things called selection sets. This is again a core SolidWorks feature, not part of the sim stuff. Selection sets let you hold faces in memory, and you can pre-select them, or you can select them again later like I did just now. Let's throw in, I'm going to do something pretty low, but let's say about 20 psi inside the firebox. It's kind of arbitrary made up number. Okay, how did I do that selection set? That was pretty cool. A selection set. Back to our model tab. Again, just a way to save pre-selected faces. All you need to do is hold Control and pre-select whatever faces that you want. Okay, and then right-click in the white area and say Save Selection. So I'm going to say New Selection Set. See that? Right-click, Save Selection, New Selection Set, and that's going to show up here at the top of my tree as a new folder selection. Cool. I'll finish the little tutorial here. Say you want to add one more face, okay? Pre-select it in the tree, hold Control, pick another face, right-click in the graphics area, update, okay? It's a cool trick that's in Core SolidWorks, but I can't tell you how much I use it for Sim. All right, so we applied some pressure. Notice that you can still add more forces, more pressures. You're not limited to only applying one, okay? But you are limited to only force and pressure, okay? The only loads that we are allowed to apply in a SimXpress study. All right, what's next? Choosing a material. Okay, so I hit choose material, and that takes me to the SolidWorks material database. If you have never run a sim before, you're going to notice that here on the right-hand side where it says properties, those colors are new. Normally there's not colors there. When you're running a sim study, the red text is the material data that is required. You have to have it to be able to run the stress analysis, okay? So if you are making custom materials, which is totally allowed, if you make a custom material, just make sure you have at least the red text data, okay? All right, now I'm looking through this list. I've got a bunch of steels. I've got everything else from the SolidWorks database, got all these custom materials. But I want you to notice this top area of my material properties. There's a linear elastic isotropic drop down here that I don't have access to. It's grayed out. What does that mean? Okay, these are some graphs I stole from Wikipedia. On the left-hand side, we have a stress strain curve for something typical. This was actually for aluminum. So an aluminum stress strain curve. We have the linear portion of the stress strain curve. You see that line right there on the left-hand side. And then you have the kind of plastic portion of the curve. SolidWorks simulation, or SimXpress, it only focuses on the linear elastic portion, the linear portion of the curve here. It totally ignores the plastic portion, okay? So even if you get above yield stress, it's just going to keep following that linear portion up to infinity, all right? Just following the linear line. That's one of the requirements, or one of the limitations of SimXpress. Here on the right-hand side, I just grabbed an example of a rubber material, just so you can see the difference between what a higher level of SolidWorks Sim could do. It could do these very detailed stress strain curves, okay? We're putting in actual data. If here inside of SolidWorks, linear elastic isotropic is the limitation. So not going to run rubber on this. Let's just go and do something default-ish like 304. So I'm going to hit apply. I'll hit close. And that loads in my material properties. All right, let's hit next. Okay, you think you can run it now. It says run simulation, but there's actually another hidden setting right here where it says change settings. This is the access to our mesh. If I hover my mouse over these examples, see how this is tetrahedral elements. They're kind of like pyramid shape elements. As they get smaller, they map around that curve better. I don't think I could say it any better than the picture showing. The smaller the elements, the more precise our results, the more accurately our geometry is captured. So we want to make our mesh smaller, but I don't want to make my solve time so long that this becomes a webinar of you guys just watching it run, right? So we got to be careful. I'm going to hit change mesh density. Okay, and here's what we have access to next. We've got a slider bar where I can control the maximum element size and minimum element size. This tends to be based on the overall size of the geometry, so it helps you make an initial guess. And it's unlikely to cause you to break the RAM on your computer because it's so small or anything like that, okay? It's a good initial guess. You can override these by typing in smaller numbers if you want to. That's cool. I'm going to hit reset, and I'm going to hit OK, and we're going to see if this works. It's going to try meshing this. Where I've seen it fail before in SimXpress has been around parts that have fillets on them. So if we take a look at the text on this component, the text has some fillets in the corners. That could potentially be a problem. I've seen it for weldment beams. The weldment beams tend to have fillets on them, and that can be a problem. So we just need to double check it, be careful of it, make the mesh smaller if it fails. Okay. If it continues to fail, it worked here, which is awesome. If it continues to fail, I recommend you remove the fillets. All right. Is this a good mesh? It's decent. It's good enough for a first run. It's likely not good enough for a final solve. We tend to want at least 2 to 3 elements across the thickness to really capture the bending. But this is certainly good enough for a first pass run. Okay. So I'm going to go back here and let's summarize what we just found. So linear elastic only for our materials, and then standard mesh only, right? That means it doesn't capture fillets very well. So get rid of those fillets if you're having mesh failures in SimXpress. Okay, but I think we're done. Let's run this thing. Let's get to the pretty pictures. Okay, so what we got going on here? We got it pulsing like a drum. It looks like an extreme amount of deflection. Let's be careful what we assume just by the animation, though. If I look up here in the top left, it says deformation scale 6.4. So it's multiplying the actual deformation by 6.4 to make an animation that looks really obvious what's happening. That way, in case I made a big mistake, I can correct that. So I'll say the part does deform as expected. I'm going to say yes. Let's get to looking at some results. So it looks like for this model, I've got some results that are causing yield. I've got factor of safety 0.36 happening over here by some of the lettering. Okay. Now, earlier I said that if we get above yield, some impossible results start happening, or not impossible, but we're getting past that linear portion of the stress strain curve, so we've got to be careful with how we take these results. But what I can say is, okay, it yielded, I should probably add some more material, make this a little bit thicker or something like that. That's factor of safety. What other results can we get out of SimXpress? I can see my stress results. So this is varying PSI. So what do we got? About 82,000 PSI to about, what is that? 120 PSI at the bottom, the lowest. Pretty cool. And I can look at displacement as well. And then that's just going to prove out what I said earlier. The maximum displacement is only 0.4 inches. This is, or half an inch. This is not really deflecting as much as it looks. Now that is what we can get out of SimXpress, kind of the first half of it. Stress results, displacement results, factor safety. And if we decide we want to make some changes, like, for example, I don't want to do 20 PSI, I want to do 15 PSI. You can make that change, you can rerun it and modify your results that way, okay? Okay, done viewing results. I want you to remember these two options, generate report and generate e-drawings file. I'm going to show you what those look like while the optimization runs, okay? For now, I'm going to hit next. So optimize your design. Would you like to optimize it? Yes. Okay, so it is generating this thing called a Design Express study, and it's picked up this model dimension that I actually don't have in my tree yet. So let me hit cancel and just pop back over to model and pull this down. So what I did is I went ahead and added in like an extra layer of thickness on a side of the firebox, and we're going to vary that thickness in the optimization tool. Okay, currently it looks like it's 0.2. Let's go back to the DesignXpress study, select the dimension, and there it is picking that thickness, whatever it is currently right now. I'll hit OK. And let's vary that from, let's go 0.1 to like 0.5. Great. What's next? Okay, the dimension range, I already did that. Specify the constraint. Okay, so that is, I'm just used to this interface. I'm going to use this interface. This constraint thing, I got to drop down. I got 3 things I can pick from. Factor of safety, max displacement, or max stress. And the idea is I'm saying, hey, don't go above blank number or below blank number. So I'm going to make sure it's greater than a factor of safety of 1.5. Let's try for that. Let's see if we can get that good. All right, that's our restraint. And then I've got my goals. My only choice is to try to minimize the mass. So I like this. Let's kind of say this a different way. I'm going to vary the thickness of one piece of the firebox while aiming for a factor of safety greater than 1.5, but still trying to minimize the mass. So keep this part file as cheap as possible to make. Now that I'm good, I'm going to go ahead and click Run the optimization. As that gets going, let's summarize. Okay, so for our design study, for our optimization, we can only change one dimension on our part file. I can only constrain it by one constraint, which is either stress, displacement, or factor of safety. The goal has got to be minimizing mass versus something like minimizing stress. So first up, if I had hit Generate Report earlier when I was in the SimXpress study, it would have taken a bunch of snapshots of my study and ended up with a Word doc like this. Now, this is a template that comes with your install of SolidWorks. So all this kind of title block stuff and where the pictures are laid out, that's all in the default template. You can do some modifications of this template if you choose. So take pictures of things like what the bodies are, what the materials are, gets you those material properties. Okay, where did I define the fixtures and the loads? What did I do for the mesh? And then it's going to take some kind of standard screenshots of your mesh and your results, okay? This is a good thing to keep in your back pocket in case you overwrite the results or lose the results at some point. At least you have kind of a general spit out of data. So that is the Generate Report option. The other option was generate an eDrawings file. eDrawings is a free file viewer that anybody can download. You don't have to own SolidWorks to download it. And again, it's free. You can send people your SolidWorks files or specifically eDrawings files, and they can open them. They can navigate around. They can do section views. If you allow them to, they can measure and kind of get an idea of what's going on in the model. So again, another great way to share your sim results with people who might not have access to SolidWorks or SolidWorks Sim. Notice that we're not seeing the iterations that it's running. If it's doing 0.1 inches, half an inch, like we don't see what it's doing. We don't see those results. In the PowerPoint, I had mentioned that where you only see the optimal result, you don't get to see the iterations in between. So hey, this didn't converge. And unfortunately, that means we don't even get optimal results. That sucks. Why didn't it converge? Well, it probably never got above a factor of safety of 1.5, so we never got to see the results. With that, that's going to finish up my SimXpress stuff. So let me just go back to my model tab and kind of close this down. It'll ask me to save it. I'll hit yes. Okay, now that's finished. Let's switch back to the larger part here. I've got the smoker part file. And this is still the multi-body part. So this has many, many, many parts in it, 32 to be exact. And we're going to run the studies on these. I'm not going to run them live. It does take a few minutes to solve. So what we're going to do is jump to final results when it's time to do that. So go ahead and add in SolidWorks simulation. Now, when I say add in, what do I mean? So I've got SolidWorks. This is going to our website. Go to our SolidWorks dropdown, SolidWorks Sim, SolidWorks Simulation. Here, we've got a lot of good videos introducing what the tool is. If you want to go back and check these out after the webinar, I recommend it. They're fairly short, minute and a half. It's a really great way to quickly get an idea of what's possible. I'm going to take us to the matrix. The matrix shows us the 3 separate licenses of SolidWorks simulation that exist. So we've got simulation standard, right? Simulation professional, simulation premium, the 3 levels. The videos that have the green play button, those are the modules or the functions that we get with that license. So with simulation standard, I've got static analysis, motion time-based, and fatigue analysis. GoEngineer has a free video explaining all of these. It's a little free training that we've got. So I'm not going to go into every single one. We're just going to focus on the static analysis for this type. Let's get back to SolidWorks. All right, our simulation is added in, and we've got our 3 tabs here at the bottom that have my completed studies. So already we're seeing that you can have more than one study, where SimXpress you couldn't really do that. Let's go to Sim. Let's go to a new static study. I've, of course, got the highest level license, so I've got access to a lot more than what somebody would see in Sim Standard. But I promise you, I'm not going to show you anything that you don't have access to in at least Simulation Standard. Okay, so another pop-up popped up on my other screen that said calculating joints. It's turning these beam members into some chickenpox looking things, okay? These are called beam elements. They're one of 3 types of elements that we can get in Sim Standard. I've got an example. Oh, not in that PowerPoint, but this PowerPoint. So a beam element. It takes a structural member and it simplifies it into its moment of inertia and a cross-sectional shape, the length, things like that. And then out of it, you can get things like your shear diagrams and your moment diagrams, as well as things like stress and displacement. It's really good for assemblies that are just made out of beams, like bridges or skids. For this example, just to keep things simple, I'm going to ignore all the beam elements. That makes it take longer to solve, unfortunately, but it'll make it faster to set up. Now we need this new 2021 feature, treat all solid bodies as solid. It's going to convert everything over. All right, let's start thinking about our comparisons. So let's compare this back to SimXpress. Right away, we can see that where we were limited to a single body before, I could do single bodies, I could do multi-bodies, which I'm doing now. You could totally do assemblies. No limitation there. Let's go check out what the limitation is on fixtures. All right. If I right-click on fixtures in my tree, I've got access to way more options than just the fixed that we had in SimXpress. These choices, they are macro buttons just to help you do a bunch of different things, but they're not really very different from each other. They're just kind of like individual degrees of motion controlled in various ways, okay? The most generic type is this use reference geometry, or really either one. It's use reference geometry. What I can do with it is say, okay, each of these individual faces, I'm not going to allow them to move, but I'm going to control which directions they're not allowed to move. So we kind of come down here and we click these icons. See the green arrows popping up. The green arrows are, hey, it can't move in that direction. I'm limiting it from moving in that direction. And so the idea would be we'd go through and we'd click all three. Now I did that the slow way, the manual way, just to show how much is possible with the fixtures here in this actual simulation license. All right. I think that's enough of a restraint on the smoker. You think so? I think so. So what did we find out? We have control over all 6 degrees of freedom. What's a degree of freedom? It's the 3 translational directions, X, Y, Z, and the 3 rotations. So rotation about X, rotation about Y, rotation about Z. So I can keep it from moving or move it in any of those 6 ways. All right, what's next on our list? What can we do for loads? Well, if you read the description of the webinar, you saw that I was going to apply a temperature load. So you probably already know that's what I'm going to do. So we're not going to do a pressure load this time. We're going to take a look at this whole list of types of loads that we can do. And I'm going to pick temperature out of the list. Let's just take a second to look at the vast array of options we have in comparison, right? I've got a gravity load, so that could be weight analysis of the whole thing. Centrifugal for spinning, bearing loads to replace the pins that you've got, and temperature loads, of course. So let's go into a temperature load. I'm going to select all my interior faces. Hope I remembered to make a selection set. I did. We'll grab those. I don't remember what temperature I did for the other study. I think I'm just going to set 300 degrees Fahrenheit. Oh man, it says Kelvin over here. Does that mean I have to convert it to Kelvin? Nope, you don't. This is a drop down. You could drop it down to Fahrenheit, Celsius. I think those are 2 other choices. So 300 degrees Fahrenheit. Switch it over, Kelvin. Cool. All right. So we've got our temperature load applied to all my interior faces. And at that point, it's just a mesh and a run. It does take a few minutes, so we are going to go to the complete analysis. Oh, what am I doing? I totally missed the material step. Anyway, we got force, pressure, temperature, bearing loads, so much other stuff. Let's go figure out what we're limited with our materials. I'll just show you that in the complete study. Okay, let's remember what linear elastic is. Linear elastic is that linear portion of the stress strain curve, right? So just the elastic modulus. Here in my complete study, you saw it take a second there. It had to load the results in, so it took a second. Let's see what materials I applied here. Yes, I'm going to delete the cut list. That just expands out all my parts. I applied plain carbon steel to pretty much everything. The fast way I did that was right click and there's like apply favorite material and just do it like that. It's very easy. Or you could do all bodies. But I did override one of these. See if I can find it. Here we go. So in the firebox, something I ignored in the previous study. We've got a layer of insulation in here. People who design smokers, they do this to kind of keep the most of the heat inside the firebox because they don't want it leaking out and not getting to cook the meat. So we've got that layer of insulation modeled in here. So I went in and I changed that material to ceramic porcelain. Of course, I could also use a custom material. So just notice that you don't have to have only one material applied to each part or each body. You can totally have different ones per part. Now, if I go into that library and we take a look at this model type dropdown that was grayed out before, I have now only 2 options, linear elastic isotropic and linear elastic orthotropic, which is good for things like wood, which has different elastic modules in different directions. But that's it. That's a limitation. Okay, so we're still stuck on that linear portion of the stress strain curve. Limitation in Sim Standard. All right, that's enough talking about the setup. Let's get into what's cool with the results, right? Yeah, so linear elastic Um, with the mesh, you can do far more meshes, right? We talked a little bit about that with the beam elements. A lot more control over what types of elements you're using, and a good measure for helping you around fillets and things like that. Okay, let's check out the results. So just like with SimXpress, we get some defaults like our stress plots, our displacement plots. We can do factor safety if we really wanted to. But there are some ways to go a little bit further. This is our stress results, looks pretty cool. The first thing we can do is, I want you to notice this deformation scale. Just like in SimXpress, it's amplifying our results to make it look more obvious what's happening. If I jump over to displacement, you're going to see that my deformation scale jumps from that 230 to a deformation scale of 1. So you have control over these various settings, yeah? So I can do that. Check out my unit system over here. It's no longer in inches. It's in mils or thousandths, so thousandths of an inch. Just help me see what's actually going on there. So 60 thousandths of an inch. All of that is controlled through these edit definition, these chart options. Lots of control over our plots. The cool thing I want to show you from here, though, is the probe tool. This is how you can get a lot of numerical results out of our pretty pictures. So probe lets me kind of click on various nodal points and get the results out of there. I think it's loading up. I can click on various points like so. It's pulling data. I will often use onSelect entities and generate a whole face worth of numerical data that I can then sort max to min and kind of get a bunch of data like that. So with that probe tool, you can pretty much get a numerical result on any point of the 3D geometry, okay? Including section views. If I cut it in half, I'd be able to probe on the cut face. That's kind of option one I've got here. That's different from SimXpress. Another type of result that we don't have there are the resultant forces. So resultant forces are free body forces. I'm going to right click on results and get that there. So how much reaction force is on the bottom of the smoker? How heavy is it, for example? How much is the thermal expansion kind of causing a load on these faces? So it looks like on this face, I've got 230 pounds of force pushing down on it. That's kind of stuff we can get there. What's something else cool? Let's go to free body force. A free body force works on faces that aren't restraints, something like this, that might normally be welded to another piece of geometry. And we can see the load that's been transferred through that face. That's interesting, but where it's more commonly used is in weld sizing analyses. That's a whole other discussion, so I'm not going to get into that today, but I'll kind of show you like a little preview of what the concept is. You'd be selecting edges or faces and extracting the force per length on that face, okay? And then you size your welds that way. Okay, so that's some ideas there. Let's get back here. Let's look at some results. Cool. So what kind of stuff can we get out of Sim Standard? Stress results, displacement results, factor safety, a lot of other kind of cool plots. We got our probe tool to get our numerical results. We got our reaction forces to pull reaction forces, reaction moments, free body forces. And then I didn't show you this, but you also have connector forces for your virtual bolts, springs, screws, pins, etc. Let's get into the last step here. Let's take a look at a Sim Pro setup. So while I bump over to those, let me show you what that's talking about. So Sim Standard is what we were looking at. Sim Professional has access to this other large category of modules. And I'm focusing on this thermal analysis one. With thermal analysis, I can do temperature distributions. So range of temperature from one side to the other. It's heat transfer, it's conduction, it's radiation, and convection. But then the cool thing is I can take those temperature results and I can bring them into a static study and get thermal stress. All right, so how did I set up this thermal analysis? We're not going to do it from scratch, just kind of give you an idea of what's possible. I set up some hot air assumptions blowing through the center of the tank. So on this, those are the outside air. So I have outside air at 70 degrees Fahrenheit blowing along the outside, cooling it off. I've got, I think, 300 degrees Fahrenheit air blowing along the inside of the smoker. And then I've got about 500 degree air blowing along the inside of the firebox. Just some assumptions based on interviewing a few pitmasters out there, but the firebox can get quite hot. The fire burns at what, 1,000+ degrees Fahrenheit. And in the smoking area, some people cook it at 200, some people cook it at 400. So it's a huge range. I think we made a good assumption though. So once I apply those kinds of loads to the system, we can output results like temperature distribution or heat flux from various phases. Cool. Looks like I did a section view so you could see through it. I kind of wanted to show you this, that insulator material is really stopping that heat load from kind of passing out to the outside air. That's why you see that real cold spot right above it. It's pretty cool. It's working well, right? Good insulator. Maybe I overkilled the insulator. So once I've got thermal results, I go over to another static study. Okay, so we've got our static study. The only thing I set up here is this thing called thermal in the external loads. The way you set this up, right click on your loads, and you go over here to thermal effects, or if you're really cool and you have SolidWorks flow simulation, you go to flow effects. Thermal effects is this pop-up, and you go pick your thermal study with the temperature results you want to import. It brings those in, and it determines the stress to that temperature load. Yeah, pretty straightforward, but just different ways that you can take advantage of the different levels of these tools. So SimXpress, no temperature data, but we could do pressure. Sim Standard, we could just apply a straight temperature on faces. And then with Sim Pro, I can do a thermal distribution and import that in. Pretty cool. All right, there's so much more I could show you guys. I love this tool for many reasons, mostly that it's so iterative that I can figure out answers in a couple different designs in 20, 30 minutes, and I can walk away very quickly. It doesn't need to be a whole day affair, and I love it for that. I love how intuitive it is. There's so many great tutorials and validation examples and just stuff online from other users that help make it so easy to learn too. And then of course, GoEngineer is here to help. If this is your first time seeing SolidWorks Sim, maybe you don't even have the license, maybe you only have SimXpress, but you want to start using it, please reach out. Reach out to me, reach out to anyone that you know from GoEngineer. We'll find somebody to help you get you started.